Hi everyone, welcome back to a new video, and today we will talk about biochemistry and the 5 first step of glycolysis. So basically, glycolysis is the net equation of the first 5 steps of glycolysis is to turn glucose and 2-ATP into glyceraldehyde 3-phosphate, or 2 molecule of glyceraldehyde 3-phosphate. So for the first step in the glycolysis, it's going to be a group transfer reaction with the enzyme kinase, or the enzyme type being kinase, and it's going to use ATP to create glucose 6-phosphate and ADP. So how this works? Here is a glucose molecule in the Fischer projection. The oxygen here, or the lone pair on the oxygen is going to attack the phosphorus atom here. That is the electrophile, and then this pi bond is going to go and roll for us to obtain an intermediate called a pentavalent. Here we can see penta, meaning 5. There's 5 atoms attached to this phosphorus. So that is our intermediate. And the group transfer, or the group being transferred, is this phosphorus group that's going to attach on this oxygen. And now the arrow are going to be, this is going to roll on the oxygen, and then this lone pair is going to roll down, forming allowing ADP to leave, and then forming our product, or final product of the first step, being glucose 6-phosphate. For the second step of glycolysis, it's going to be glucose 6-phosphate being transformed into fructose 6-phosphate. So we're going from an aldose to a ketose, to a ketose here, where the double bond is on the second carbon. All right. So for us to move this double bond, we will be doing an isomerization. So the first thing here, we have our glucose 6-phosphate. The first thing will require us, wait a second. Yeah. Our first step is going to protonate this oxygen here. So the lone pair is going to go and attack this proton. So we're going to protonate this oxygen here and have a base deprotonate this hydrogen from this carbon for this bond to roll down and create a double, or carbon-carbon double bond. Now we have an ene-diol intermediate. We can see an ene-diol being an hydroxy group, or 2 hydroxy group bonded to a double, or a carbon double bond. So this is our intermediate. Now what we want to do is to go and have this carbonyl group there. So for that to occur, we will need the deprotonation of this hydrogen here, and then the bond between the oxygen and the hydrogen is going to roll down and form that double bond. But now we would have 1, 2, 3, 4, 5, which would exceed the octet for this carbon. So this pi bond, being a nucleophile, is going to attack this hydrogen and form a new bond on this carbon here that would lack one bond, because if this double bond leaves, then he's left with one bond here, one bond here, one bond here, and we know that carbon, for their octet, they want to be bonded to 4 atoms. So then this would leave us with the carbon being bonded to 2H, 1 hydroxy, and then to this carbon here. So this product here now is fructose 6-phosphate, and we obtained it by doing an isomerization with the enzyme type isomerase. Alright, so now for the third step of glycolysis. For the third step of glycolysis, going to be another group transfer reaction where fructose 6-phosphate plus ATP is going to give us fructose 1,6-bisphosphate plus ADP. So here what's important is to locate bisphosphate. Instead of being B-phosphate, bis means that there's 2 phosphate group in this molecule, but they are separated by carbons. They are not on neighboring carbons. Biphosphate would be on neighboring carbon. Bisphosphate, in this case, their phosphate group is here, and then there's one here too. So our previous product from step 2 being fructose 6-phosphate, it's just like the first step. So we are going to do a phosphorylation of this oxygen here. So the lone pairs are going to attack this phosphorus, and then this pi bond is going to roll up, and then we're going to obtain an intermediate called a pentavalent, and then same thing, this bond is going to roll on this oxygen, allowing ADP to leave, and this lone pair on an oxygen is going to roll down for reforming the PO double bond, and then we will obtain the product being fructose 1,6-bisphosphate. So this is the third step of glycolysis. And the fourth step is basically the breaking, or we're breaking in the middle a carbon-carbon bond to form a glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So here we have our fructose 1,6-bisphosphate, and we want to obtain 2 product here, or 2 3-carbon product. So one trick I have, or I tell myself, is that the breaking is going to occur between the 3rd and the 4th carbon, so we have 2 products, or 2 3-carbon product. All right, so the CC bond breaking, first of all, you can locate your carbonyl group, and then this carbonyl group is going to be protonated, and this other side here that is, or the 4th carbon here, is going to be to become a carbonyl group. So this hydrogen is going to be deprotonated, allowing the bond to roll down, forming the carbonyl, forming a carbonyl group, and then the bond between the C and the bond between the 3rd carbon and the 4th carbon is going to roll and form a carbon-carbon double bond, because this carbonyl group here got protonated, so we're left with 1 bond, 2 bond, 3 bonds. So this carbon is lacking 1 more bond to achieve its octet. So we are left with these products here, so this bottom product here, I did it wrong, but so this product here is the one up top. So we're now left with a C double O, so C double O, and the same thing goes below. So in here we can locate an aldehyde is formed there. So this sometimes help myself remembering this is our glyceraldehyde 3-phosphate. So this is the right product for the fourth step. But for the other product here, there's an enediol formed, right? So we have an OH with our 2 hydroxy groups separated by a carbon, or attached on both carbons of the carbon-carbon double bond. So we want a dihydroxyacetone phosphate. So for this to occur, we want to create another carbonyl group. So to create another carbonyl group, this hydrogen here is going to be deprotonated, allowing the bond to roll down. And then this double bond, being nucleophile, is going to attack this acid, and then it's going to go and bond here, because now with only one, or with this being a single bond, it's going to be 1, 2, 3. This one is lacking one bond for its octet as well. So what's left is our final products here. So we have our carbonyl group here, carbonyl. This one attacked, went here to have this CH2OH, and then we have our phosphorus group up top. So those are both of our product for the fourth step, which are glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. So now you might remember me saying that the net equation for the first 5 steps of glycolysis is, or the product of the net equation is 2 molecules of glyceraldehyde 3-phosphate. So in here we have already glyceraldehyde 3-phosphate, but we also have another molecule of dihydroxyacetone phosphate. So the 5th and last step that we're going to talk about today is the transformation of dihydroxyacetone phosphate to a glyceraldehyde 3-phosphate. All right, so the 5th step of glycolysis is going to be an isomerization, and it's going to transform the dihydroxyacetone phosphate into a glyceraldehyde 3-phosphate. So for this to occur, we need to move this double bond here to form the aldehyde that we talked about earlier. So for this to occur, we are going to protonate this oxygen and deprotonate this hydrogen for this bond to roll down here and form a carbon-carbon double bond. So this is our intermediate. Now that the bond rolled here, formed a double bond, this one is protonated. We have both of our hydroxy group attached to both carbon of the carbon double bond. And the last step is for us to have the nucleophilic double bond attack this hydrogen that is going to now attach to this middle carbon, because this one here is going to form a carbonyl group, forming our aldehyde. And now we have our glyceraldehyde 3-phosphate. Carbon 1, carbon 2, carbon 3, phosphate. So glyceraldehyde 3-phosphate, and we also had another glyceraldehyde 3-phosphate coming from the 4th step. So after 5 steps, we have lost 2 ATP, but have gained, or have now 2 glyceraldehyde 3-phosphate for every molecule of glucose phosphorylated, of course. So the first 5 steps of glycolysis are usually referred to the investment stage. So the first 5 steps are usually investment stage because 2 ATP are used. And we will learn a little later that the steps 6 to 10, which are the last steps of glycolysis, are the payback steps because we then form 4 ATP and other stuff as well, or other energetic stuff. So this is why we named it the first 5 steps as investment, because we invest 2 ATP to eventually gain and produce ATP and other energetic molecule. So I hope this helped. If you have any questions, just let me know, and we'll come back soon and talk about the steps 6 to 10. All right, thank you for listening.